Hi, my name is Tooba. I'm a PhD student at King's College London, and I'm presenting our work on automated quality of service monitoring for 5G and beyond using distributed ledgers. It's a joint work by myself, Damiano from University of Cambridge, Nishant from University of Surrey, and Simone from Vodafone. The overall idea of this work is to enable quality of service monitoring through distributed ledgers in a tamper-proof and transparent way such that both parties can trust the system. What is our motivation for this work and what are the problems with the current service contracts? For example, somebody wants to check their email or do online shopping, service level guarantee might not be their requirement. But if a autonomous car is passing through an area where they will be relying on online navigation services, service level guarantee is their requirement. Second point is it is not always easy and necessary for the operators to provide service level guarantee. In the areas, there will be areas where custom operators will have limited access, and in those cases they will not be able to provide guaranteed service contracts, and in such cases the operators can always offer their customers a cheaper contract without service level guarantee, and in the areas where they can provide service guarantee they can offer the contracts at a higher price with this guaranteed service contracts. We can say that we advocate a specific contract for every use. For example, with respect to place, use, and time. The example of the contracts can be, for example, if somebody wants a contract for 12 hours, if somebody wants a contract for 10 hours, or if a customer wants contract for 12 hours, or 2 hours, or 4 hours in off peak or on peak. It depends on their use and the purpose and the time. So, or we can say just in time. Two of our work are already published on this topic. One is on MobiArch and the other one is in ICBC. In MobiArch, we propose an end-to-end architecture with smart contracts. And in ICBC, we show how to implement this architecture with using network slicing. In this work, we focus on monitoring of the promised quality of service with, if it was delivered. Why we need this? We need this because smart contracts, they don't have any built-in mechanism to monitor if the data entered to them is valid or the data is correct. For example, if somebody records the quality of service through smart contracts, wrong metrics through smart contract to the ledger, smart contract don't have any mechanism to check and verify if the parameters are correct. And we propose a mechanism in this paper which actually solves this problem. Let's discuss the components of our architecture. We have a customer device, we have an operator device. They both are equipped with accumulators. The service provisioning is discretized into small epochs or time intervals. We maintain per packet state within each epochs. The advantage of the epochs is that you don't have to write every packet details to the ledger. It's not feasible. You cannot achieve this with line rate because PDLs, they have their own latency, so all the nodes on the PDL, they have to agree to a transaction before it's written to the ledger. So it is important that we gather the packets within each epoch, and the state of each epoch per packet state is both the customer and the operator, they are aware of it, but the whole world doesn't know it, and we share only the summary of the service provisioning or summary of epochs. We share them to the ledger. The higher the resolution of monitoring we want, the finer should be the epoch. And the service, when the customer is agreed to a quality service provided to them, they send a receipt to the operator and they move the epoch. At the end of the service provisioning, if there is no dispute, all the receipts are recorded to the global ledger. But what if there is a dispute? So let's discuss the scenario when we have a dispute. Same example, we have a customer device equipped with accumulator, we have an operator device, and we have service provisioning discretized into time intervals or epochs. So service provisioning starts and the customer starts sending receipts to the operator. and the dispute occurs. As soon as the dispute occurs, all the previous receipts to which the customer already agreed are recorded to the ledger, and the state channel is closed. Another advantage of using epochs is that even if it's a dispute, the operator will lose the payment for the last epoch only, and they will get the payment for the rest of the service provisioning to which the customer has already agreed. So let's discuss intra-epoch state via accumulators. So what are accumulators? They are secure cryptographic data structures and provide membership proof. We need accumulators because we are dealing with distributed ledgers in this work, and with distributed ledgers, every node has to approve the transaction before it's finally recorded to the ledger. And with receipts, if we start writing every receipt to the ledger, it will take some time for every node to approve the transaction, and we cannot achieve line rate. We record the quality of service in a tamper-proof way every epoch using accumulators. So we gather packets every epoch and before the receipts are sent, and each party keeps the record of the service provisioning independently at their end. The two type of accumulators we compare and contrast in this work out of several options available. The two type of accumulators we compare and contrast in this work are Bloom filters and RSA accumulators. Now let's discuss if just-in-time is possible or not. In this work, we used accumulators to record the quality of service metrics. We installed accumulators on both ends, and we added packets to accumulators for each epoch and send the receipt if the customer agrees to the quality of service provided to them. We did add packets in accumulator. It means that we want to check if we can achieve the system on line rate. To answer this research question and to measure this, we did compared and contrasted two type of accumulators. First are the Bloom filters, and the second is RSA accumulator, and we did measure the add operation in both of them. When we measured the add operation on a Bloom filter, we see that it took around maximum 0.09 millisecond to add one packet to a Bloom filter. It means per second we can add around 11,1111 packets, or we can achieve 5.688 megabits per second. We did the same experiments on a resource limited device, which is a Raspberry Pi, and we see that it took around 12.05 milliseconds maximum to add one packet to a Bloom filter on a resource limited device, or we can say 82 packets per second, or 0.0419 megabits per second. When we did the same experiments on an RSA accumulator, we see that it took around 2 seconds to add one packet on a faster machine, and the same experiments on a resource limited device, for example, Raspberry Pi, it took around 20 seconds to add only one packet for us. On this note, we can say that it is not a workable solution. RSA accumulators is not a workable solution for us at all, because if we use RSA accumulators, we will have to wait 2 seconds to add another packet, another 2 seconds to add another packet, and using this technique, line rate cannot be achieved at all. So on this note, I would like to conclude our work and say automated quality of service monitoring is the requirement for 5G and beyond, and it is achievable if service level agreements are monitorable and accountable. We say accountable because we want when the service level agreement is agreed, it must be honored. And if it is violated, the affected parties should get paid as soon as possible without any delay. And we want monitorable because all the parties involved in the agreement should be able to monitor the service levels at their end independently. The second point we advocated here is the dynamic and flexibility. So service contracts should be offered as per the requirement of the user and the capability and capacity of the operator. That is achievable through smart contracts because they provide an automated system for service provisioning, and distributed ledgers because distributed ledgers are immutable, so all the parties, they can always go back, check and verify if the service level was met or not, or the service level agreement was honored or not. And also we mentioned that smart contracts, they don't have any built-in mechanism to check and verify if the data entered to them is valid. So we provide a monitoring mechanism through state channels and cryptographic accumulators. And we mitigate this problem of smart contracts, and we ensure that the right and the correct service levels are entered to the distributed ledger. On this note, I would like to say thank you for listening to our talk.